In this video, we're going to explore trade more formally by using some mathematical examples and using graphs to think through it. And I'm going to motivate this discussion by thinking about, again, two people, Alice and Bob. And we're going to be thinking about them in terms of imagining a small-scale society where they're the only people around. Okay, so we've got a small deserted island, and in fact, we're going to start with it being so deserted that it doesn't even have two people on it. We're going to start with just Alice on this island, and we're going to think about what she can produce if she's there all by herself. Now, we're going to assume there are two different things that Alice can produce in a given day. One thing she could do is she could catch fish. The other thing that she can do is weave blankets, maybe by using, dried palm fronds or something else that might be on the island. We're also going to assume that she always prefers more of either or both of these goods to fewer. Okay, she never gets full of eating fish. She never gets too warm by having too many blankets. Okay, so those are her two productive possibilities. Set her off to the side, at least for the moment. And let's think about how good she is at producing each of these two things. All right, so we've got Alice. And let's say that when she is spending her time catching fish, she can catch one fish per hour. Okay? When she is spending her time weaving blankets, she's not as good at that. It takes her 3 hours to produce one blanket. And so another way of saying that is that she could produce 1/3 of a blanket per hour. And let's also say that she has 12 hours a day in which she can produce these things. Okay? Now, on the right-hand side of this page, we've got a graph here. I've got fish on the y-axis and I've got blankets on the x-axis. And we can think about kind of her trade-offs if she's producing one of these goods versus the other. So suppose that Alice was producing only fish. Okay, she spends all 12 of her hours per day catching fish. Well, in that case, she's going to catch 12 fish. She's going to weave 0 blankets, and that puts us here on this graph at this point 0, 12. Okay. What about, on the other hand, if she spent all 12 of her hours producing only blankets and she didn't spend any time catching fish? Well, now obviously she's going to have 0 fish and she's going to have 4 blankets. If you divide those 12 hours that she has by the 3 hours per blanket it takes for production, that puts us right here on the graph. Okay, 4 and 0. All right, now what I'm going to do next is I'm going to draw a straight line between those two extreme points. And this line here is what an economist calls a production possibility frontier. So let me write that out. Production possibility frontier, or a PPF. Okay. Now this production possibility frontier, it shows us every possible combination of fish and blankets that Alice could produce in a given day. Okay. For example, say she starts up here with 12 fish and she decides, well, really I want to have at least one blanket. So if she wants to get one blanket, she can do that by taking away 3 hours from catching fish. That would move her down to having 9 fish. And then she can use those 3 hours to produce one blanket. Okay, and that would put her right there on the production possibility frontier. If she was to want to produce a second blanket, she could do that, but it's going to take 6 hours of her day. That means that she only gets to take 6 hours to catch fish. She spends the other 6 hours weaving blankets, so she would get 6 fish and 2 blankets, and so on down this line. And you can imagine, if you're willing to imagine her catching fractions of fish, okay, you've got this entire, or weaving fractions of a blanket, you have this entire straight line between them. Okay, now remember, we said that she always prefers more fish to fewer fish, and she always prefers more blankets to fewer blankets. So she would, if she could, she would like to consume, some bundle out here where she's getting, say, 12 fish roughly and 8 or 9 blankets. But she can't do that in a day because she can't produce that much in a day. Okay? You can think of this as kind of being a fence, and she can't get past this fence. Now, she could consume, let's say, 2 of each, 2 blankets and 2 fish if she wanted to, but she has no reason to do that because she can produce more of either both, more fish, more blankets, or more of each of those goods. Okay? So we don't expect her to consume anything to the left and below this production possibility frontier. We would expect her to consume everything that she produces. All right, so left to her own devices, she's going to consume at some point along this straight line, this production possibility frontier. Okay, so that's what would happen in a world where we had Alice all by herself. But now we're going to let Bob wash up on shore, and we'll see how that changes the situation. Okay, now we've got Alice, and we also have Bob, and we're going to assume that Bob's strengths are exactly the opposite of Alice's. Okay, specifically, if he fishes, it takes him 3 hours for every fish that he catches. And so could also say that he can catch 1/3 of a fish per hour. If Bob weaves blankets, he's actually better at that than Alice is. He can weave 1 blanket per hour. Okay, and we can also say he has 12 hours of time available to him as well. So if we put his production possibility frontier up here, we would say if Bob spends all of his time catching fish, well, takes him 3 hours per fish, he's got 12 hours. He could catch 12 fish doing that. On the other hand, if he spends all of his time weaving blankets, he can produce 1 per hour. He has 12 hours, and so he could produce 12 blankets if he was willing to produce no fish on his own. And just like with Alice, we can draw a straight line between those 2 points, and that gives us his production possibility frontier. So this blue one I've labeled PPF with an A subscript. It's Alice's production possibility frontier. For the red one, we'll call that PPFB, Bob's production possibility frontier. Okay, and so you can see, one of these 2 parties is better at catching fish. The other one is better at weaving blankets. And now you can imagine them specializing, right, and trading with each other. So one of them is going to focus on fishing, the other is going to focus on weaving blankets, and in this case, it's perfectly obvious who should be doing what, right? Alice is clearly a lot better at catching fish than Bob is, so she should be the one catching fish. Bob is clearly much better at weaving blankets than Alice is, and so he should be the one who is weaving blankets. This is a situation of where each of the 2 parties has what we call an absolute advantage. Okay? An absolute advantage means that you can produce more of something than your trading partner can. All right? And in this case, Alice has an absolute advantage in fish. Whereas Bob has an absolute advantage in weaving blankets. And in this situation where you've got 2 people and each has their own separate absolute advantage, they should specialize in those absolute advantages. Okay? So we're going to have Alice catching fish. We're going to have Bob weaving blankets. And now let's see what comes of that. Okay, what ends up happening. So what I have over here is a little table where A stands for Alice and B stands for Bob up in this line. And then in this line, F stands for fish, the number of fish that they have, and B stands for the number of blankets that they have. So both Alice and Bob are going to produce a certain amount, and then they're going to trade with each other. And we'll write down the results here, and then we'll put them on this graph over here. Now, we said she's going to be spending all of her time fishing. He's going to be spending all of his time weaving blankets. So what does that mean? That means that at the stage at which they produce, Alice is going to have 12 fish, Bob is going to have 12 blankets, and they'll each have 0 of the other good. Okay? So they've gone out, they've spent their 12 hours, her fishing, him weaving blankets, and now they come back at the end of the day to trade with each other. Now, one important question, important to them in particular, is what's the trade ratio, or what is the price that they would be paying, okay? For every fish that Alice hands over to Bob, how many blankets does he have to give back to her? Okay, what is the price in blankets for a fish? Or what is the price in fish for a blanket? And we're going to start, to keep this simple, we're going to assume they trade at a ratio of 1 for 1, okay? For every fish that Alice gives to Bob, Bob has to give her back 1 blanket. And also, to keep this simple, we're going to assume that they each trade half of what they've got. So they make 6 trades at 1 for 1. Okay? Well, what would happen there? Alice is going to give 6 of her fish to Bob. So he's going to get a 6 in his fish column. She produced 12, gave up 6. That means she has the other 6 left for herself to consume. In exchange, Bob is going to give her 1 blanket for each fish that she gave him. So he's got to give her 6 blankets. So we'll put a 6 in her blanket column. And he started with 12. He traded away 6. That leaves him with 6 blankets. Okay? Well, what does that look like on this graph? Well, if you're Alice, you've got 6 blankets and 6 fish, and so you're going to be consuming at this point right here. If you're Bob, you're also getting 6 fish and 6 blankets, and so I'll just highlight that point by giving it kind of a red halo to show that both of them are consuming at that same point. Okay, that would be at 6, 6 on this graph. And now here is what is really remarkable about trade. Okay, remember that on her own, if Alice was the only person on this island, she would have to consume at some point along this blue production possibility frontier here. She can't get past that that barrier, that fence, I called it earlier. Same thing for Bob. On his own, if he was on the island and he didn't have Alice around, or if he refused to trade with her, well, then he wouldn't be able to cross this barrier either. But notice that together, if they specialize and trade with each other, not only are they both being made better off, as we talked about in the first video, but they are both being made better off than either could make themselves. Okay, they're able to sort of break the barriers of their own production possibility frontiers if they're willing to work together, if they're willing to specialize in one task and trade the surplus off with each other. Okay, the reason why that works, why both of them can have more, is effectively, Alice produces 12 units. If she was on her own, for every unit that she of blankets that she wanted to receive, she would have to give up 3 fish. But with Bob, he can actually give her 1 blanket for every 1 fish that she trades to him, and so she can get outside of that blue line. She doesn't have to follow this curve. She could follow a line that goes 1 to 1, okay, across here. Same basic logic goes for Bob. All right, so that's it for this video. I just wanted to illustrate that with specialization and trade, both parties can get more than they could have produced on their own. In the next video, we're going to think about what would happen if you tweak this price ratio around. Okay, if you charge more blankets per fish, for example, or vice versa.